So apparently our solution of using those tiny thrust washers did work. And I'll demonstrate that in a second. So those little washers, I suppose I could show you one. And I can tell you where and how I got them. So we're looking at this little guy right here. Oh yeah, he just dropped. There he is. Looking at that guy right there. So he's a 2mm, and he's a tiny washer, and I'm pretty sure I got him on eBay from Orchid Sound. That's where I usually, where all those trucks and stuff we built, I got all the screws and the washers and stuff from Orchid Sound, and I got those to be thrust washers. So we put them in to our guys right here, and they seem to work. Now we got to do, we got to test what motor are we going to put in this guy. Okay, so we need a motor for this one, and I'm going to have to say I've tested these motors here. This one is an FK130, 24 volt, not that great. Not for this purpose, not that great. The Johnson, the huge Johnson 6-pole, which is awesome, is just too slow. The 280 is also wickedly awesome because it draws like no power at all, but it's too slow. Then we got the ancient Lexus motor. Since this is a one-off build, this 24 volt Lexus rear view mirror motor that you can't even buy anymore, he didn't test that great. So, as usual, it's going to come down to our face ripper. The face ripper seems to be the guy for this. So the face ripper is a Mabuchi 266. And by 266 I mean that it is a size 2. Johnson is just a bit bigger than a size 2. Here's a size 1. Here is a size 1. Okay, FK130, size 1, length 3. 3-pole. Face ripper is a 280. It is a size 2, length 8, 3-pole, wickedly powerful 32 volt motor. Actually, I think it's a 36 volt, but I can't, my tester doesn't even go up that high. It's got ridiculous torque, but for this purpose, since we're doing a gear reduction everywhere along here, we don't want one that's that slow. So the face ripper is pretty fast. So I put a piece of silicone hose on here, and I'm going to attach him right there to this guy. Let's take our pliers and go ahead and attach him. And here's the thing. The instructions give me no details. I don't get any details from the breakdown on how that motor was offset like that. It doesn't show like there's a gear tower or anything. But since we can build superstructure around it, we can do this. We can do this just like this. Let's get him behind this lead weight. Okay, let's get him behind the lead weight, and we'll use our silicone hose. We use our silicone hose to do this, and I was thinking we need silicone hose everywhere, but turns out we actually don't. Let's get him on there so he's nice and stable. Okay, so he's on there. All right. So this is where the cab sits. And what we're looking for is if these two guys, if what we did, and with what we did with the thrust washers, that totally works. So let's give them a try, and we're going to use our we're going to use our guy right here, our conveyor, and we're going to turn him up. Hold it. Let's turn him down. Turn him down to 1.6 volts. Let's see what's happening. What? You're turning? At 1.6 volts, face ripper always turns. And if I hold him here nice and steady, I hear nothing. I don't know about you, but I hear nothing, and everything's turning. No sounds. Interesting. Very interesting. I'll leave him there for a minute. Now look up here again. So we are at 1.6 volts, and you can see the amps fluctuating because he is wobbling. All right, so if I hold him, notice those amps are topping out at 0.1, and we're at 1.67 volts, and he's still turning. So then if we turn him up, okay, so on my layout, DCC, we're talking about 18 volts. But let's turn them up to, like, say, operating speed around a third, around 6 volts. 6.93. Right? Now I'm going to hold them in place. Check out the number of amps we're using. It's almost nothing. I'm going to try to stall this. Here we go. Full stall. 0.4. Full stall. Look again. Nice, right? Oops, he just broke loose. And we just went to the floor. All right, so he totally broke loose, but he did do the job, and we're going to set him back up again. I don't have the lead weight locked down yet. So let's put him back on here. Let's put them back together. Put them on here again. Let's connect them up. Let's see how far we can go with this guy. Nothing's locked down at all, other than the two differential, where they basically transmit power from across. They go from across to straight down on each one of them. All right, now let's get this guy going again, and let's see if we can't just hold him. And let's turn him up too. So on my layout, 12 volts is 2/3. I'd have to say that whatever we did for the with those thrust washers in there, it did work. Now, can I get those two guys inside the nuts here so we don't have to worry about them? Yeah. It's working. So I'm pretty sure, and if you can see here, that's the cab area, and look, here's the edge of the locomotive. We could put a face ripper in on the side and do it that way. I think that's what we're going to do. And we're only at 2/3. You want to listen to it when it is all the way? If you listen to it at 18 volts, well, how about 24 volts? Huh? If 18 volts isn't good enough. There's 25 volts right there. Now, our controller doesn't go up to 25 volts. But the 266, which is a size 2, length 6 pole, totally does. Now that's rare earth magnet. So, or rare earth metal brushes. All right, here's normal operating. Not bad. Not bad. I'm surprised that we could do this. I didn't think we could actually get these guys together based on what terrible shape they were in. but we did. And those two trucks, or those two guys right there, I didn't think we could get them to operate, but we did. But now here's the problem. Next thing is, if you can see here, where can you see it? There you go. There's one. You see that joint right there? That goes down to a gear, and we haven't yet figured out exactly which part is going to do that. That goes down into the trucks to turn the wheels. But we will, and then we're going to test it.